Okay.
Not like that.
Wow. Yes, you think.
What's happening to the commission? Everyone will keep our routine. I was gonna know.
We did this together.
Yeah. So I guess the point is to be careful. Are we good?
Yes.
Are we rolling?
I can see.
Some action.
Action.
Okay. All right. Okay. Welcome back to those that will be joining us. I'm not sure if all of you have been able to come back. Thank you for joining us. So we're talking about the Madlanga Commission in class. They want to buy me wheels, so I'm going to be cycling. They wanted to buy me wheels.
Yeah, it has changed. Yeah, it has changed.
Hey, Dilo, they change cheese. Hey.
Yeah.
Yeah, as you think people love you, ne? Until
If you love that.
Exactly.
guys, let's do chemistry too and stop politics. All right, so they say indicators generally represented rather as HIN, right, are organic compounds which display characteristic colors when placed in either an acidic or basic solution, right? So they are generally weak acids which will ionize in water to reach dynamic equilibrium. Now, I want you to see this. Firstly, it's a reversible reaction, right? Which means it will reach dynamic equilibrium. Now, I want you to think about it. Which means in an acidic medium, what am I going to contribute? What does an acid give me? An acid will always, let's make an example with hydrochloric acid. What does it give me? It gives me hydronium ions, right? So, which means if my solution rather is in an acidic medium, I have got an increase in hydronium ions, and as a result, what's going to happen to my equilibrium? It means, in this case, an increase in hydronium ion concentration will now favor the reverse reaction. Nagon? Right? Because now I've got more of these guys. Okay? Now, what's going to happen? It means that my solution is going to turn yellow in an acidic solution. Nyabon guti why? Nyabon? Do you see it? Right. In a basic solution, I think, is that what you were trying to ask me? What if you added a base? I'm still going to answer the question, but were you asking Uguti what happens if they add a base? 6.7.2, okay, it's fine. So in a basic medium, what does a base give me? So if I make an example with sodium hydroxide, it dissociates and it will now give us hydroxide ions. Are you guys with me now? What do hydroxide ions do? They will now take away the hydronium ions to form water, right? So which means when I introduce hydroxide ions, these guys get excited and say, look, let's go and grab ourselves hydroxide ions, and ultimately they form H2O. Are you with me now? So by introducing hydroxide ions, please, I want you to realize this. You are decreasing the concentration. It means as they go and react with hydronium ions, they are now going to decrease. The hydronium ions are going to decrease, right? That's the change. And so what happens? A decrease in the concentration of hydroxide ions will favor the forward reaction. Nagon? Right? I'm going to take something away, equilibrium wants to replace it. Okay. So it will now favor the forward reaction. So now it means that my solution is in turn going to become blue. So what am I saying? In a basic medium, right? This indicator would tend to form to turn blue. Okay. Guys? Right. But of course, if you've got neutral, what's happening? We've got a combination of both yellow and blue. Escape a crash. Ne? So when you mix yellow and blue, what? Green. Yeah, so which means in neutral solutions, your solution will tend to be green in color. You see, you can take the person out of the crutch. Ne? The person lives with themselves. So probably they were going to still do the same thing in another asas. Okay, so the question says, bromothermal blue is an indicator which is yellow. So Nibonile white turns yellow in an acidic medium, right? This is what I was saying. If we are in an acidic medium, rather yellow in an acidic medium and blue in an alkali, state what is meant by the term weak acid. Now we know what is a weak acid. It's an acid that dissociates. Remember, a base. No man, what am I saying? No, that ionizes partially, incompletely, right? In solution to form a low concentration of hydroxide ions. Huh? Did I say hydroxide? Yeah. Hydronium. Okay. Yeah? Guys, now find your own thing. All right, now they say to us, by referring to Le Chatelier's principle, explain why bromothermal blue displays a blue color when placed in a solution of sodium hydroxide. So this is exactly what I just showed you, right? Yes. Then? Of what? Unfortunately, there's not much I can do about it. Is the quality of the video?
Yeah, the same is not clear.
Oh, okay. All right. Sorry for those of you that are online. Apparently, the quality of the video may not be clear. I'm not sure if it's on our side or yours, but please, if it's possible, just try to increase your bandwidth as well. Okay, or the resolution of your screen. Right. So, what did we say? By referring to Le Chatelier's principle, explain why bromothermal blue displays a blue color, right, when placed in a solution of sodium hydroxide. Now, so what's going to happen? The addition of sodium hydroxide will increase the concentration of hydroxide ions. Okay? So that's the first thing. I want you guys to be mindful of that. But hydroxide ions react, or in this case, hydronium ions are attracted or react with hydroxide ions to form H2O. All right? So that will cause a decrease. So H3O concentration will decrease. Okay. Does this make sense, guys? So that's the first one. Do you guys have a question? This solution is already at equilibrium, if we can start there, right? So what does that mean? If I add something in equilibrium, but how will equilibrium be disturbed? It means I'm introducing hydroxide ions which react with this hydronium ion. Okay? So in this case, it means I am decreasing. If hydronium ions are taken away, it means they are decreasing. So this is the part I was I was coming to. That hydronium ions now begin to decrease. That's the gahle gahle. If you were to ask about this, that's the change that takes place. Right? So the addition of those will decrease the hydronium ions. So now, I'll come back to your question if there is. Ne? So now, with a decrease in hydronium ions, we will favor the forward reaction. Why is the forward reaction favored? To try and replenish or increase the amount of hydronium ions that are there. Are you guys with me now? Right. So H2O concentration decreases. All right. So the forward reaction, forward reaction is favored, or you can say the equilibrium shifts to the right. Okay, is favored to replace hydronium ions and so remember, if I favor the forward reaction, it means that there'll be an increase in the amount of hydronium ions as well as In minus, which is blue in color, and so our solution will turn blue. All right, so Lorraine, you had a question.
You know, when I read that, I thought that it is like the sodium hydroxide solution, it's a full solution, like we're not adding it to the.
That's still the same concept. Okay.
No, because in the explanation there, I think that the explanation wouldn't have the hydronium ions, it would just be right there.
Okay. Remember, where are the hydronium ions? In the indicator. The indicator is this whole thing. Right? So, the indicator has all of these properties in it. But as to whether it turns blue, it turns blue or it turns yellow, depends on the solution that I put it in. Okay? So if I put it in an acidic medium, as I was saying, if I was in an acidic medium, it means the indicator itself now begins to get more of these hydronium ions. The indicator favors now the reverse reaction. Okay, and it turns yellow. Okay, but now you are putting it in a basic solution which has hydroxide ions. So the hydronium ions in the indicator now react with the hydroxide ions, right? And in this case, it means that we're going to favor the forward reaction, and it means our solution is going to turn blue. Sharp. Beautiful stuff. Alrighty, beautiful, beautiful. Right, so I'm assuming that 6.7 we're okay, nah? Right, so what I wanted us to do, I don't know Guti by way of time, but I just wanted to go through the acid and base part. You did the KC portion of it, dang it? Right, I wanted us to jump to this. Now, please, for the sake of time, I know that we've already, I think number 1, 2, and 3, we can answer it with ease, ne? Calculate the original volume of acetic acid. I wanted us to skip to 7.2. Yeah, do you mind? Can we do 7.2 together, ne? Okay, and then Sizokbona by way of time how things are looking. All right, so there we are. 0.5 cubic decimeters of hydrochloric acid with a concentration of X. So we don't know the concentration of our acid, right? But we are adding it to 0.8 cubic decimeters of a 0.25 moles per cubic decimeters of sodium hydroxide. Now, please, I want you to remember what do we need to keep in mind? How does hydrochloric acid react with sodium hydroxide? Plus H2O. Okay? Right, so it is a 1-to-1 ratio, right? That's a balanced reaction, it is a 1-to-1 ratio. So they say, at the completion of the reaction, it is found that 0.12 moles of hydroxide ions is present in the solution. Now please, can I just stop here? What does this mean? Yes, sir.
It means that sodium hydroxide is in excess.
Right, it means that sodium hydroxide is in excess. Right? That's very correct. It means sodium hydroxide is in excess. So, which means this acid and a base, we did not titrate this time around. Ne? We didn't measure, because when we are titrating, we are going to measure the amount of base that we need to neutralize with the acid, or even the other way around. We're going to measure the amount of acid that we need to neutralize with the base. Guys, right? But what did we do this time? We just added the two together, and now we find out at the end we still have some hydroxide ions that remain not neutralized. Does this make sense, guys? All right, beautiful stuff. So the question is, calculate the concentration of hydrochloric acid solution. So let's do this. What is our limiting reagent? So it means the acid will be the limiting reagent, right? Why? Because I have an amount of hydroxide ions that still remain after the reaction, right? So these will be in excess. Now, again, you must remember this reaction. Number of moles original, or you can say initial, will be equals to the number of moles that react plus the number of moles in excess. Where can I apply this? In a number of moles in excess. Which one has number of moles in excess? It's the hydroxide ions, right? It's the sodium hydroxide. Does it make sense? So I can get the excess amount, but do you also agree I can find out what the original amount is? Right? Why? Because they not only gave me the volume, but they also gave me the concentration. Never. Guys, when you approach this section, think of this equation. Okay? Right, I've noted your hand. Ne? I just want to complete this train of thought. So what will this give us? Isosnigers are the number of moles of sodium hydroxide that reacted. And if I can find what reacted for sodium hydroxide, then I can find out how much of the acid was there. Does it make sense? Okay, right. You had a question, Lebo? They gave hydroxide ions in excess. So these are the ones that remain even after the reaction has taken place.
So we need them to find the original or the reacted.
We can find original. We were already given original amounts. Look at this. They gave us the volume of sodium hydroxide. They gave us the concentration. So this is before the reaction took place. Okay, this is what was there for sodium hydroxide before. So what I'm saying is we can find out the original amount from what is given. But we can also find out what is in excess, what remained afterwards, right? And what will that give us? It will give us the amount that reacted in that case. Is this okay, guys? No? Right, okay. Right, so let's go for it. Let's find out first the number of moles that started, the original number of moles. Or you can say the initial number of moles. That's going to be concentration times the volume. Okay, what's our concentration? 0.25. Okay, sorry, so that it doesn't distract us. There it is, 0.25. What's our volume? 0.25 multiplied by 0.8. Okay, what does this give us? 0.2 moles, right? So this is the original number of moles, and remember we are dealing with sodium hydroxide over here. So we've got the excess hydroxide ions, and please, I want you to also remember, how does sodium hydroxide dissociate? It will become Na plus OH minus. Now what am I trying to say? The number of moles of hydroxide ions will be the same as the number of moles of sodium hydroxide. Right. So I've got the number of moles of hydroxide ions. So number of moles in excess for sodium hydroxide will be equal to 0.12 moles. And that is because that is a 1-to-1 ratio between sodium hydroxide and the hydroxide ions. Right. Please check in if there are any questions from the people online. Our online people, is that right as well? Okay. So, yes. They're asking which question paper. So this is a paper, it was a prelim preparation a paper that was made by Gudwano. Okay, yeah, the organization. So 0.12. So can I get number of moles that reacted? Of course we can. So that will be initial minus the number of moles in excess, isn't it? 0.2 minus 0.12. And please talk to me. 0.08 moles. Now what are these? What's this? The number of moles that did what? That reacted. Who did they react with? With the acid. Do you see? Right? Now, if I know the number of moles of sodium hydroxide that reacted, all I now need to check is what is the ratio in which sodium hydroxide reacts with hydrochloric acid. Hey, that hand is intimidating.
No, it's not. Some perhaps from the student, they're saying, please re-explain.
Re-explain. Okay. Which portion?
I think it's what you're doing now.
What I'm doing now. Okay. Right. Okay, so I'll go back and re-explain, and hopefully it will make some sense. Okay. I'm gonna go back to explaining. Now look at the question. We had 0.5 moles, 0.05 moles rather, of hydrochloric acid, 0.5 rather, cubic decimeters of hydrochloric acid. We don't know what is the concentration. We're at 0.8 cubic centimeters of 0.25 sodium hydroxide, but this one, manje, is what we have, is what we start with. Even with the acid, that's what we started with, right? But they tell us at the completion of the reaction, we still have hydroxide ions. Now, for those of you that may be listening, the fact that we still have hydroxide ions that remain unused tells us that it means we had more of the base than we had acid. It means that the limiting reagent for this reaction, the reason why it stopped, is because we ran out of the acid. Okay, so I hope that that does make some sense. So what we said is we can find out the number of moles of base, which is sodium hydroxide, that were there, and that's why we were able to find concentration times the volume, and we said 0.25 multiplied by 0.8, 0.2 moles. Please note, what are these? These are the original moles of sodium hydroxide. That's what we were given right at the beginning. But because sodium hydroxide ionizes in a 1-to-1 ratio, so we said sodium hydroxide becomes sodium plus OH minus. They gave me the moles of hydroxide ions in excess, the ones that remained after the reaction was completed. So these are the excess moles, which means we're now going to say the excess moles for sodium 1-to-1 ratio together with hydroxide ions. So those are the excess moles. And so these together gave us the moles that reacted. Remember, we are still talking about sodium hydroxide here, right? So this is 2. So we said the number of moles that reacted. I want you to think about it. If I take what I start with minus what I have at the end, it will tell me what I used. Always, okay. If you go onto a taxi, 20 rand, right? And you pay, they give you 5 rand change. How much is the taxi fare? 15 rand, ne? West, right? So how do you get that? Right? You said, well, what I started with, which was 20 rands, minus what I have in excess, which means the change is what was in excess, right? So what does that give you? The actual taxi fare. It's the same analogy, that what I start with, that's the original number of moles, or you can say initial number of moles, minus what we are left with, what is in excess, right? So that gave us 0.08. So we said 0.2 minus 0.12, and this gave us 0.08 moles. So these are the moles of sodium hydroxide that were used. Is it right, Anget? Is it right? But I reacted and moles. They reacted with hydrochloric acid, right? So now I know that the two react in a 1-to-1 manner. For every 1 mole of sodium hydroxide that I use or that reacts, also 1 mole of acid reacts. What does this mean? Any number of moles of sodium hydroxide will require an equal number of moles of hydrochloric acid. Does that make sense? Right. So, number of moles of sodium hydroxide that reacted will equal to the number of moles of hydrochloric acid, and because it is a limiting reagent, it means it's the hydrochloric acid that was used. All of it was used, right? So this will be 0.08 moles. But do you remember what they've given us? We're looking for concentration, right? Now we've got number of moles, we've got the volume for the acid. So I can say concentration of the acid will be number of moles divided by the volume, right? So I've got 0.08. What was the volume of acid that was given to us? 0.5, right? That is divided by, 0.05. Let me try and just erase and move these things here. So this is divided by 0.5. And what did we get for our final answer? 0.16. And remember, we are dealing with concentration be in moles per cubic decimeters. Are we all good in the hood? Is that right? Okay. So ngiyamcela ne? Please, when you're going to be dealing with acids and bases, keep this reaction, this thing in mind, especially when it comes to back titration type questions. Be able to identify, was I given the initial, or am I given excess, or am I given the reacted amount, right? So that is what we are going to use most of the time. All right, now let's go for it. The next question. They said, is it right? Any question? Okay. Right, so the next question. I almost know what they are going to ask about. They said calculate the concentration of hydroxide ions at the completion of the reaction. All right, talk to me. When the reaction ended, what did we have? We had the number of moles of hydroxide ions, right? But what are we looking for? The concentration, which means concentration is number of moles divided by volume. What was the number of moles that were left? 0.12. But now, what's the volume that we have? There we go, right? What did we do? We added the acid with the base, right? So the hydroxide ion now exists in the new mixture, the new solution, isn't it? Okay? And we added 0.5 cubic decimeters with 0.8 cubic decimeters. Konye, what does that give us? 0.5 plus 0.8, that will give us 1.3, right? So 0.12 divided by 1.3 gives 0.09. 0.09 moles per cubic decimeters. That would be the concentration of hydroxide ions. And now they say calculate the pH of the solution at completion of the reaction. Can you calculate pH? Not yet. I like that answer. Why not?
Because we have the concentration of the hydrogen.
We don't have the concentration of the hydronium ions. Remember, every time calculating pH, we're going to say that's minus the log of the hydronium ion concentration. But we don't have this. We've got the concentration. We've just calculated the concentration yani yama hydroxide ions, right? Right. So now let's start with that first. Where do we begin? We're going to assume this happens at 25 degrees. They didn't tell us. Concentration of hydronium ions multiplied by the concentration of hydroxide ions is equal to 1 times 10 to the power negative 14. Sisonke it, guys? Right. Funama hydronium ions. Hydroxide ions 0.09, and this is 1 times 10 to the power negative 14. And you can divide both these sides by 0.09. Now we've got the concentration of our hydronium ions, right? Please give me that number there. 1,1. 1,1. Negative 13. Okay. Moles per cubic decimeters. Can I now calculate the pH? Yes, we've got hydronium ions this time. So we can be able to calculate the pH of our formula, right? So we're going to say pH is minus the logarithm of H3O plus concentration, but we've just found that that's going to be minus 1.11 times 10 minus 13. And of course, we are assuming, we know that this is a base, so it has to be greater than 7, right? And what do you get there? 12.95. 12.95. And that's going to be the pH of our solution. Is good, is nice? Is it right, guys? All right, beautiful. I'm hoping that for those of you that are also online, you are getting this. And by the way, if you also watch all the videos that I've done on acids and bases, you'll see that this is essentially for these back titration or these long questions, right? That will always be the case in terms of the formula that I've used. Number of moles that you have initial will be equal to the number of moles that react plus the number of moles that are in excess. And I promise you, if you just remember that, that will help you towards answering these questions. Okay, right. If Bengombuso Benzoti, for you online, give me my things. Okay, Bayang Zama, all right. Are there any questions in relation to the question that we just did? Are we all good? All right, awesome stuff. I think let's leave it there for today. Now, before I close, for those of you that are joining us from our channel, please do note that because of exams that are running at this moment, our usual programming will kind of be disrupted. We will announce, I think it has already been announced on the lives that we will have, but please do also check out the videos that we'll be publishing, where I give you just a breakdown on how to go about doing mathematics as well as physical science, but also do continue using the videos to try and get yourself ahead. So thank you for joining us. Yebo, there's a question. Yes.
Is it from the pH that we got?
Yeah.
Is it being classified as a strong base?
Gonja, what was our pH value?
12.95.
Yes, absolutely. That would mean that we've got a strong base in that case. Okay, we've got a strong base. All right, 12.95 does tell us it's a strong base. And I mean, it makes sense, né? Sodium hydroxide is a strong base. So, yeah. So thank you for joining us. We'll see you guys again next time. Shop. Buy a donkey. Okay. Okay.